So students, in this video, we are going to solve a question which came on 24th January, first shift of JEE Mains. The question says, a gas of certain mass closed in a filled cylinder at a pressure of 3.23 kilopascal has a temperature 50 degrees Celsius. The gas is now heated to double its temperature and we have to find the modified pressure. Well, let's solve the question. The solution will, of course, emerge from the ideal gas equation. And here it's been given that the mass of gas is certain, which implies the number of moles will always be constant. R is, of course, a universal constant. And volume is considered to be fixed because in the question it's been given that it's a cylinder. Now, focus here. If it were for JEE Advanced, they should have mentioned that it's a rigid cylinder. But NTA didn't bother to write an extra word. But it's usually assumed if they have given it to be a cylinder, it will be a rigid cylinder. Now, so volume will be fixed, N is constant, R is constant, pressure will be proportional to temperature. Now, this implies that final pressure upon initial pressure will be equal to final temperature by initial temperature. Now, this pressure is in kilopascal. This is also in pascal or kilopascal. Kilo just means 10 to the power 3 and the unit is pascal. Temperature is always considered to be on Kelvin scale. So unless it has been explicitly mentioned that an operation, be it multiplication, division, addition, is being operated on Celsius scale or Fahrenheit or any other scale than Kelvin scale, you don't have to do it on any other scale than Kelvin. For addition and subtraction, you can consider Kelvin equivalent to degree Celsius, but whenever you are multiplying, for example, in this question, we are multiplying the initial temperature by 2, or if you are dividing temperatures, then you always have to consider Kelvin scale until and unless it's been mentioned that you have to do it in any other scale. So here we will consider that the final temperature will be equal to 2 times initial temperature and Tf by Ti will be equal to 2. This implies that Pf by Pi also will be equal to 2 from this relation. Now, the initial temperature in the question is given to be 3.23 kilopascal. Final pressure will simply be double of this, which is 6.64 kilopascal. Or in other words, you can write it to be 6460 pascal. This is the correct answer. But the anti-answer is 3730 pascal, which is wrong and the question should be challenge. Well, this was the matter of the video, but we will go on further to understand what was the mentality of NTA behind writing the answer as 3730. Well, so if you consider the doubling of temperature is happening on Celsius scale and then try to calculate the answer. So 50 degrees Celsius will be 273 plus 50 Kelvin and 100 degrees Celsius will be 273 plus 100 Kelvin, and you calculate Tf by Ti, it comes out to be 373 by 273 plus 50 gives you 323, and you multiply Pf by Pi will be equal to Tf by Ti. This gives you, using these two equations, you can calculate Pf comes out to be 3730 pascal. Now in the question it's been given that the gas is heated to double its temperature. In thermodynamics, we always considered any operation on temperature to be in Kelvin scale. And here they wanted, without even saying, to do the calculation in Celsius scale. Well, this is the level of laziness of NTA. They didn't bother to write one extra sentence to make it explicitly clear what the student had to do. That's why this question should definitely be challenged, and we will keep on posting these kind of videos whenever you find some mistake in any of the questions.